So this is all we are discussing for a convex lens. Okay, all this we have done for a convex lens. So for a convex lens, we know that when the object is at infinity, the image is formed at focus. Image is real and inverted. It is formed at focus at f, highly diminished. What about when the object is at 2f? When the object is at 2f, then what happens?
It is real and inverted. And
Okay, real and inverted. And Moksha?
Yes,
Moksha, what
sir.
about the image characteristics when the object is at 2f? Moksha, can you unmute yourself? Moksha, if you can hear, you can also respond through the chat. Okay, your mic is not working properly. Okay, Moksha, no issue. So you should inform, right? Just keep me informed. Okay. So Sudhanshu? Yeah, Sudhanshu and Dharya. What about your cameras? Just keep them on. And when the object is at 2f, so where is the image formed? Sudhanshu, where is the image formed when the object is at 2f?
So, near 2F.
Yeah, image is at 2f. At 2f and it is same size. Real and inverted. Same size, real and inverted. And what about when the object is beyond 2f?
it is formed diminished.
It is formed diminished and it is formed between f and 2f. It is found between f and 2f. And the image is real and inverted, it is diminished. Okay, if you are aware of all the things, do not worry, we are going to raise the bar. We are going to increase the level of questions. Okay, let us first start here. We are starting here just now. We'll be increasing the level of questions at each stage. Okay, at each stage, you will be getting different types of questions. So beyond 2f, the object is between f and 2f. And when the object is placed between, when you place the object between f and 2f, so you get the image beyond 2f. It is beyond 2f, real and enlarged. Then we did when the object is at f. Now the last diagram is left when we place the object between f and 2f. So how many of you can draw the diagram for the object placed between f and 2f?
Sir, I'm writing, sir.
Yeah, it will be upright. So just draw in your notebook quickly, draw the diagram for the image when the object is placed between f and 2f.
Sir, I was writing, sir.
Okay, previous one.
Yes, sir.
Okay, so no issues, you will be getting that in the PDF. I'll send that in the PDF.
Okay, sir.
So you can start drawing.
Sir, which one you should draw, sir?
Now the object is placed between O and F. Object is placed between optic center and focus.
Okay, sir.
So you need to draw that when the object is placed between optic center and focus. So here this is your, we make this to be the optic center O. Then 3 centimeter mark, we are getting it F. Then this mark we are getting 2F. Here we have 9. then 12. Optic center, focus, 2F, F and 2F. So this is F1, 2, F1, F2. Sorry, I'm making them in the opposite order. Yeah, it's here. They have 2F1, F1 and F2 to F2. Make your lens with the help of a compass. I'm just drawing the lens simply without any compass. So your diagram should be neat and clean with the help of a compass. We have this lens and we keep the object at between F and 2F. So here we have kept the object anywhere between F and 2F. So let's try to make the image. Again, our rules are, we'll follow the rules here. We'll use a ray of light passing parallel to the principal axis. So the ray of light that passes parallel to the principal axis, it will pass through focus after refraction. So after refraction, we have the ray of light passing through focus. The second ray of light, we take it to be passing through the optic center. Okay. So we observe the two light rays to be diverging away from each other. Right? We see that the two light rays, they are diverging away from each other. So here, if I am observing from this side, I will observe the light rays to be meeting at, to be appear to meet. They are not actually meeting, but the ray of light will appear to meet in the backward direction. We will observe the ray of light to be meeting in the backward direction. Somewhere here, it will appear to us that the light rays, they are coming from a common point like this. Okay. So do the light rays appear to meet at a common point? Yes or no? Do we observe the light rays to meet at a common point?
Yes, sir.
Yes. The light rays, they are not actually meeting. Actually, they are diverging. See how the light rays are going. We observed the light rays to be traveling like this. So this was the light ray going like this, like this. So this one traversed through optic center without any deviation. Now we observe that the distance between them is increasing, so they do not meet anywhere. Here on this side, they are not actually meeting, but they appear to meet at some common point. So now we will draw where they appear to meet. That is the point where we will have the image. So our image will be formed at a point where they appear to meet. So at this point, we get the image. So it's not 2F. You can get this image at any point. Okay. You can get this image at any point before the lens. You will not say that we are getting the image at 2F. You will say that we can get the image at any point beyond 2F, behind the lens. So what type of image is it? Can we write the image characteristics here? Shan? Shan?
Yes, sir.
Okay. Can you tell the image characteristics?
Sir, the image is upright.
Okay, image is upright. Any other thing? Okay, what will I call the image? Should be real or virtual? Shan, is the image real or virtual?
It's virtual.
Yeah, image is virtual as it is formed by the appearance of the light rays to meet. It appear to meet. So the image formed is virtual. And So we have talked of the nature of the image. The nature of image is upright and virtual. So upright, you can also call it to be the erect. When the image is upright, we call it erect. Okay. And what about its position? Where is the image formed? Yes, where is the image formed? It is found behind the lens. And what about its size? Dharya, what can we say about the size of image? Dharya?
Sir, the images of magnified.
Yeah, image is magnified, image is enlarged.
Yes,
So we
sir.
say image is enlarged or magnified. We can say the image is magnified. Image is enlarged or image is magnified. So this specific condition of the lens, when we have the object is placed between optic center and the focus, we get an upright image which is enlarged. Okay. And so this specific condition of the image formation is used as or makes this convex lens to be used as a magnifying glass. So I hope you must have observed a magnifying glass.
Yes, sir.
Okay. So let us see how does a magnifying glass, is the working of the magnifying glass same as we have studied about this lens. So it's the same thing. Your magnifying glass, see, if you can observe in any of them, see here, the magnifying glass, with the help of the magnifying glass, we are able to see smaller characters to be bigger. Okay. You can use, I can show you here magnifying glass here also. Just if you use them, you will be able to get. Okay. So you have a magnifier. Here you can use that magnifier. If you use your magnifier in your windows or anywhere, see, the screen now seems to be highly magnified. Got it? Yes. So this is the use of the magnifier. Okay, how I'm okay, now I need to turn it off.
Sir, go
So
down, sir. With
I need to go down.
yes,
Yeah.
sir.
Okay, here. Yeah,
Yes, sir.
here.
Click on that. Yes, sir. And go up, sir.
Okay, once I click, I need to go up.
Yes, sir. Sir, left side.
Yeah, yeah. Uh,
Yes, sir. Up,
okay,
sir.
this one. Okay, so I need to close it now, magnifier.
Yes, sir.
Okay, the same thing. The similar thing happens with the magnifying glass. You are able to see these small images to be bigger ones. So where do you think, what should be the distance between this magnifying glass and the object? Any rough idea? What should be the distance? Should it be greater than the focal length or less than the focal length? Yes,
Sir,
should
greater.
the, it has to be, does the distance between the lens and the object, whatever we are looking at, does it have to be greater than this or less than this?
Less, sir.
It has to be less than the focal length, right?
Yes, sir.
The distance between the lens and the characters, whatever we are reading, it has to be less than the focal length. As we observe here, that the image, virtual and enlarged image, is obtained only when the object is placed between optic center and focus.
Sir, in,
Yes,
sir, in my diagram, this The image was formed behind that 2F1, sir.
It's not necessary that it's formed behind the 2F. Okay,
No,
it
sir,
may
it
be,
came, sir.
yeah,
Sir, it was formed like this, sir. In my
yeah,
drawing.
it can be formed before also, it can be formed after also, depending on where we are placing it. So where
Okay, sir.
it is, the image is formed, you will say that image is formed before the lens.
Yes,
Image is just formed before the lens. So anywhere before the, behind the lens or before the lens, you get the image. Depending on this, there are certain questions on the basis of this question. So I hope you have understood about all the ray diagrams for drawing the convex lenses.
Yes, sir.
Okay. So just for a quick revision, all of you should be attentive now. And let me see who can answer these questions. Okay. So if I want to obtain a magnified and real and magnified image of an object. So where should I keep the object?
Sir, at F1.
At F.
Sir, between
No.
2F and F1.
Yeah, I will be keeping it between 2F and F1. F1 and 2F1. So if I keep it a object over there, I will get a magnified and real image. So where shall I keep the object if I want the image to be of the same size?
2F1.
2F1. Okay, very good. Now let's move do quickly the image formation by concave lenses. Once we are done with the image formation by concave lenses, we can move further to the tough questions of this chapter that involves using the lens formula. So see, the next one is the image formation by a concave lens. Since a concave lens is a diverging lens, you have to use your scale and everything. I'm just drawing it without a scale. And I'm drawing it without scale, without any of those compass and all. So you should be using that to obtain a good and accurate image. So here, let me mark the optic center O. The distance here F1. Let this be 2F1, F2, and 2F. So you have the distance here of O, F1, 2F1. This is F2 and 2F2. Now, if I keep the object at infinity, there are only two cases for this. If I keep the object at infinity, so I will be getting the image to be formed at focus. So that one we have done. Let us keep the object at a finite distance at any place, maybe at 2F, before F, or at before O. We keep the object anywhere before the lens. So if I keep the object anywhere before the lens, suppose I keep the object here, and let's see where will be the image form. Okay. So to have the image formation, we take a ray of light parallel to the principal axis. So a ray of light passes parallel to the principal axis, and after refraction, the ray of light passes in such a way that it appear to pass through focus. So here if you'll observe, the ray of light should appear to pass through focus. It should appear to pass through focus and be refracted in the same direction, like this. So the ray of light is going like this, and here it appears to pass through focus. So this is the ray of light traveling. Now the second ray of light we take to be passing through the optic center. Here we are taking the second ray of light, it passes through the optic center. Now the two light rays, they are not actually meeting at any point, but they do appear to meet between O and F. At a place between O and F, the two rays of light, they appear to meet. So we will have the formation of image between O, and F. So can you draw the ray diagram for this? Yes. Can you draw the ray diagram for this situation? Yes, just tell the image characteristics for this. I told you all to be active and responsive during the class, but I'm not getting any of the responses.
Sir, could you repeat the question, sir?
Image characteristics. Image characteristics for the image formed by concave lens.
So the image formed is virtual
It
and
is
erect.
Okay, it is virtual and erect.
diminished.
Yes, image is virtual and erect, and
Diminished.
okay, it is diminished and
Formed between F and O. Optical
formed
center.
between F and O. Between F and O. So if this concave lens, it always forms a virtual and erect image. It always forms a virtual and erect image smaller than the object. Here the image formed is always smaller than the object. So the height of image is always less. Now let us see another thing. We'll discuss about the magnification at each point. So value of magnification is given by height of object over height of image by height of object. And for the lens, this is also equal to minus of V by U. Okay. So can you tell me about I'll provide you some values of magnification, and you have to tell that which lens are we using, where is the object kept, right? So if you are getting the value of magnification as +3, so which lens are you using? I'm getting magnification as +3. So which lens can provide me the magnification +3? Yeah, which lens will provide the magnification +3?
Convex.
A convex lens. For what? For which position? For which position will we get magnification as +3? Sudhanshu? Yeah, Sudhanshu? Sudhanshu? There, are you there? There?
Yes, sir.
For which position will I get the magnification as +3?
Sir, like where will we keep the object?
Yeah, where will we keep the object?
Sir, so image has to be magnified. We have to put it at 2f1.
To F1.
Yes, sir.
No. See, the image has to be magnified and virtual.
Yeah, sir.
Image has to be magnified and virtual. So this is the case of this one. See, where is the object kept here?
Sir, at over here it is at 2f1 only. Yeah, it's at 2f1. No, after s, sir.
Mm-hmm. Siddhisri? 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 Sudhamshu?
Yeah, sir. Sorry.
Yeah. So where we have kept the object
Between F1 and O.
between F1 and O, we have kept here the object between O and F1. That is A, B is the object. There you got it. The object is between A and B. The object is AB, that is between O
Yes,
and
sir.
F.
Got it, sir.
Okay. So if I want a magnification of +3, I must use a convex lens and I must keep the object between O and F. Okay. What about this if I'm getting magnification as -1? So which lens will give me the magnification -1? A -1.
Concave.
Concave always forms a virtual image, so it cannot give you magnification as negative. It will always give a positive magnification. See, you have not revised the ray diagrams. So in the next class, I will be checking all the ray diagrams. You must have drawn all the ray diagrams for the lens as well as mirrors. Okay. Draw and practice the ray diagram. See, if magnification equal to -1, what does it signify? A negative magnification, it signifies a real image. It signifies real and inverted image. It signifies that the image is inverted, and the value being 1, it signifies that the height of image and height of object, they are same. That's why you are getting the answer as plus. That's why you are getting the answer as 1. So I'm here, it's the same size. So which mirror provides you a real and inverted image and of the same size? Isn't it the convex lens when the object is placed at 2f? See, when the object is placed at 2f, this one, object at 2f, the image is formed at 2f, same size, real and inverted. So you should be able to visualize all the ray diagrams. Just keep a track of all the ray diagrams. Where is the image formed? If I have a magnification here, suppose I get a magnification of equals to +2/3. So what can you say about the nature of the image? Is it real or virtual?
Virtual, sir.
Yeah, image is virtual and its value is 2/3. So that means what about the image size? Is it enlarged or is it diminished?
Diminished.
Yeah, image is diminished, virtual and erect. So which lens does this diagram refer to? Which lens does this diagram refer to?
Sir, concave lens.
Yeah, concave lens. Okay, it is the concave lens to which this diagram refers to. Here is the diagram is in front of you. The same, virtual, erect, and diminished. This one is your object. See, here if you identify this is your object, let me mark it as AB, and you have this A dash B dash is your image. Sorry, yeah, A dash B dash is your image. What if I say I have magnification equals to -3? So which lens is going to provide me magnification of -3?
Convex lens, sir.
Yeah, convex lens. For which position? For which position will I get the magnification as -3?
Sir, object. What?
Yeah, object at
Sir,
Yes, where should we keep the object?
Between F and 2F, sir.
Yeah, between F and 2F. If I'm getting the magnification as -3, we must keep the object between F and 2F. Okay.
Yes, sir.
What about if I want the magnification to be minus 0.5?
Sir, at 2F, sir.
Not at 2F. At 2F, you get the same size. That is, magnification is -1. So you must keep the object beyond 2F. If you're keeping the object beyond 2F, so you'll get the image between F and 2F, which is small, real, and inverted.
Yes, sir.
Okay. Anyone having any doubts? Like Moksha, Ayonija, Sudhamshu,
No, sir.
Shubhansh Singh. Yeah, Shubhansh,
Yes, sir.
do you have any doubts?
No,
No. Okay, so Shubhansh,
yes, sir.
so I think everyone is clear with the image formation.
Yes, sir.
Okay. Now let's do the lens maker's formula. Oh, sorry, not lens makers, just the lens formula. So here we have the lens formula, just like we had the mirror formula. So do you remember the mirror formula?
Yes, sir.
Yeah. So in the same way, we have the lens formula, which relates object distance, image distance, and the focal length. Okay. So you write this lens formula as 1 by f. See, if there is anyone who has some work or anything wants to leave the class, so inform it and they'll leave. So do not vanish without stating anything. If you're not getting, we'll repeat. Okay, Dhairya is saying camera not working. Okay. Yeah, Moksha, what do you want to say? You can just message. Okay. So see the lens formula. It stands as 1 by f equals, it stands 1 by f equals 1 by v minus 1 by u. So this is the lens formula. 1 by f equals 1 by v minus 1 by u. And magnification here is given by height of image by height of object and is equal to v by u. Sorry, it's not minus v by u, it's v by u. I think in the previous slide I gave somewhere as minus v by u here. Yeah, it's not minus. Just take a note, it's just v by u. For the lenses, the magnification is given as v by u. So the formula is 1 by f equals 1 by v minus 1 by u. The sign conventions which are to be utilized, they are the same as we studied for the case of mirrors. The similar sign conventions we own here also. Just like the Cartesian sign conventions we have for mirrors, the same way the Cartesian sign conventions are applied for the lenses also. So here all the measurements, they are made from the optic center. The measurements are made from the optic center of the lens. The distance of the object. So again the same rule. If you have the object, towards the left or right, wherever you have the object, so the object distance will be taken as negative. Object distance is always taken here negative as the direction in which we are measuring. See, all measurements are made from optic center. All the measurements which are towards the direction of incident light, which are in the direction of incident light, they are measured positive. So for example, suppose I'm keeping the object here. Suppose I keep the object on this side. This is my object. So I keep object over here. So all the ray of light will start in the direction, will fall towards the mirror like this. Towards the lens, it will fall like this. So all the measurements from the optic center, which will be in this direction, they will be positive. So we take all measurements from optic center like this one. This measurement will be positive, and any measurement taken opposite to it like this one will be taken negative. So here we find on this side you have positive measurement, on this side you have negative measurement. So regarding the, okay, so just one. Okay, we'll discuss it further, but I think you shall be able to apply just with a small, just a minute more. We have the sign convention for focal length, which is the same. So for focal length, if it's a convex lens, for convex, the focal length is positive. Object distance, that is U, is negative. And image distance can be both positive or negative. For concave lens, your focal length is negative. Object distance is negative always. And image distance is also negative. It's not positive. It's also negative, as image is always formed behind the lens. Okay. Okay, bye all of you. I hope you have got this. Your homework is to draw the ray diagrams. Just draw all the ray diagrams of the image formation by lenses. Okay. Okay, so bye everyone.
Thank you, sir.
Bye.
Thank you, sir.